Welcome. Today, we're diving into one of the most overlooked yet powerful aspects of Retrieval-Augmented Generation, or RAG, chunking. Did you know that up to 70% of a RAG system's performance can be traced back to how you split and organize your documents? Whether you're building AI search engines or smart assistants, chunking is the backbone that determines how well your system retrieves and understands information. In this video, we'll break down what chunking is, why it matters so much, and how different chunking techniques can make or break your RAG pipeline. Let's get started by understanding the basics. Chunking isn't just a technical detail, it's the hidden lever behind effective retrieval. When you feed documents into a RAG system, how you slice them up directly impacts what the AI can find and use. If chunks are too big, you risk missing key details. If they're too small or overlap too much, you waste resources and muddy the results. The right chunking strategy enhances retrieval quality, reduces hallucinations, and unlocks the full potential of your AI pipeline. Next, let's walk through the high-level RAG workflow and see where chunking fits in. A typical RAG workflow starts with document ingestion and chunking. Large files like PDFs or HTML are split into manageable pieces, or chunks. These chunks are then embedded and stored in a vector database. When a user query comes in, it's embedded too, and the system retrieves the most relevant chunks based on similarity. These chunks, along with metadata, are injected into the prompt for the language model, which then generates a grounded answer. The quality of the answer depends heavily on the quality of the chunks retrieved. Now, let's explore why chunking is not optional in this process. Good chunking is essential because both embedding models and language models have context window limits. You can't just feed in massive documents. Chunks must be semantically coherent. Cutting mid-sentence or mid-idea leads to noisy, misleading embeddings. If chunks are too large, you might miss fine-grained details. If they're too small or overlap too much, you end up with redundant content and wasted compute. Striking the right balance is key to making your RAG system efficient and accurate. Let's now look at the first chunking technique, fixed chunking. Fixed chunking is the simplest approach. Split your text into equal-sized pieces, usually by tokens, words, or characters, often with some overlap. This method is a great starting point, especially when you don't know the document structure or when dealing with uniform content like logs or plain text. While it's easy to implement, fixed chunking doesn't always respect natural boundaries in the text, which can sometimes lead to less meaningful chunks. Still, it's a reliable baseline for many RAG projects. Next, let's see how recursive chunking improves on this. Recursive chunking starts by splitting text at high-level boundaries, like paragraphs or sections. If a chunk is still too large, it's split further, maybe by sentences, until all chunks fit within the desired size. This method is ideal for semi-structured documents, where you want to preserve logical units, but also need to cap chunk size. Recursive chunking helps maintain context and avoids cutting across unnatural boundaries, resulting in a mix of chunk sizes that better match the content structure. Let's move on to semantic chunking, which takes things a step further. Semantic chunking uses embeddings to segment text based on meaning. Instead of splitting by size or structure, it looks for shifts in topic or context. If adjacent sentences are very similar, they stay together. When similarity drops, a new chunk starts. This approach is best when retrieval precision is crucial, such as in legal or scientific documents. However, it requires more computation and careful tuning of similarity thresholds. Semantic chunking ensures each chunk is meaningful and contextually relevant, boosting retrieval accuracy. Next, let's discuss structure-based chunking. Structure-based chunking leverages the inherent organization of documents like headings, subheadings, HTML tags, tables, and lists as natural chunk boundaries. Each section or heading becomes a chunk, and if a section is too large, it can be recursively split further. This method works especially well for technical documents, web pages, or any content with clear markup. In practice, combining structure-based and recursive chunking often yields the best results, though it requires parsing the document's format. Now, let's look at the most dynamic approach, late chunking. Late chunking, also known as dynamic or query time chunking, defers splitting documents until a query arrives. Instead of chopping up everything up front, You store larger segments or even entire documents. When a query comes in, only the relevant segments are dynamically split and filtered. This preserves full context during embedding and allows for more precise retrieval at query time. Late chunking is especially useful for large, evolving document sets or high-stakes applications like legal or medical domains. However, it's computationally expensive and can increase latency. Each chunking technique has its strengths and trade-offs. Fixed chunking is simple and fast but may ignore context. Recursive chunking respects logical boundaries but can produce uneven chunk sizes. Semantic chunking delivers high precision but at a higher computational cost. Structure-based chunking leverages document markup for natural splits, while late chunking offers flexibility at the expense of speed. The best approach depends on your document type, retrieval needs, and available resources. Let's see how to choose the right method for your use case. Selecting the right chunking technique starts with understanding your documents and goals. For uniform, unstructured text, fixed chunking is a good baseline. For semi-structured content, recursive or structure-based chunking preserves meaning. If you need high retrieval precision, semantic chunking is ideal. For large dynamic datasets or when context across paragraphs matters, late chunking shines. Often, a hybrid approach combining structure-based and recursive chunking yields the best results. Experimentation and tuning are key to finding the optimal setup. When implementing chunking, use libraries that support your chosen method. For fixed and recursive chunking, tools like LangChain make splitting easy. For semantic chunking, leverage embedding models and similarity calculations. Structure-based chunking may require parsing HTML, Markdown, or PDFs. Always monitor chunk sizes and overlaps to avoid redundancy and inefficiency. Remember, the goal is to create chunks that are both manageable for your models and meaningful for retrieval. Let's look at some practical code examples next. Here's a simple code example for fixed chunking. You tokenize your text, then split it into chunks of a specified size, with optional overlap for context continuity. This approach is straightforward and works well as a baseline. For more complex documents, you might need to adapt the logic or switch to recursive or semantic chunking. Always test your chunks to ensure they capture the intended meaning and context. Now, let's see how recursive chunking can be implemented. With recursive chunking, you start by splitting at high-level boundaries, like paragraphs. If a chunk is still too large, you split it further, perhaps by sentences. Libraries like LangChain offer built-in support for this, letting you define chunk sizes, overlaps, and splitting order. This method helps preserve logical units and avoids breaking context, making it ideal for semi-structured documents. Always review your chunks to ensure they're not too large or too fragmented. To wrap up, chunking is the backbone of effective RAG systems. The way you split and organize your documents determines how well your AI retrieves and generates answers. From fixed and recursive to semantic, structure-based, and late chunking, each method offers unique benefits and trade-offs. By understanding and applying the right chunking strategy, you can dramatically boost your RAG system's performance. Remember, great retrieval starts with great chunking. Thanks for watching, and keep exploring the world of AI.